All right, since we know that we have an x-intercept at x equals 3, we can set up the general equation as y is equal to a times x minus 3 times x minus q. We also know that it passes through the point. Since we have a y-intercept at 0, 9, we know that it passes through the point 0, 9, which means we can say that y is equal to 9 when x is equal to 0. So we end up with this. And we can then simplify to get 9 is equal to negative 3a times negative q, or 9 is equal to 3aq. And that means that we can say that we divide both sides by 3 to get 3 is equal to aq. And we can then say that q is equal to 3 over a. And what that means is that we can now go back to this equation and substitute for q, and we end up with y is equal to a times x minus 3 times x minus q, which we can now say is equal to 3 over a. And so this is the equation for the family of quadratics that have a x-intercept at x equals 3 and a y-intercept at 0, 9. So for example, let's say a was equal to, let's say a was equal to 3. That would give us that y is equal to 3 times x minus 3 times x minus 3 over a, or 1. And if we work this out and expand it, we would get that y is equal to, this is going to become 3 times x squared minus 3x minus 1x is minus 4x plus 3, or y is equal to 3x squared minus 12x plus 9. Well, we already know that when x is equal to 3, this thing will be equal to 0 because of this right here. And then now we also know that it has a y-intercept of 9 because it clearly passes through the point 0, 9. We could have also replaced a with any other number, and it would still have the same x-intercept and the same y-intercept. Okay, so let's look at general formula quadratic that has a vertex at p0 and a y-intercept at 0p. Okay, because we have a vertex, we're going to use the vertex form, which is to say we're going to set it up as y is equal to a times x minus the x value of the vertex squared plus the y value of the vertex, or just that. So we get y is equal to a times x minus p squared. Now again, we know that it passes through the point 0p, so we can substitute in to get p for y is equal to a times 0 minus p squared, or in other words, p is equal to ap squared. We divide out p on both sides to get 1 is equal to ap, and that means that we can say that p is equal to 1 over a. We can go back in and we can substitute, and we can get our general equation as y is equal to a times x minus 1 over a squared. And so if a, for example, were 2, we would have y is equal to 2 times x minus 1/2 squared. And that would have a y-intercept, or it'd have a vertex at 2, 0, and a I'm sorry, at 1 over 2, 0, and a y-intercept at 1 over 2. Because in this case, we chose that p was equal to 1 over a, and we chose a was equal to 2. So therefore, p would be equal to 1/2. And so we would again have the intercepts at 1/2, 0, and 0, 1/2. Okay, so now the general form. So now we want an equation that passes through points 2, 0 and 0, 2. So that means we have an x-intercept and a y-intercept. So again, we can say that y is equal to a times x minus 2, since that's an x-intercept, times x minus q, which is going to give us, and then we can substitute in the point 0, 2, which will give us that 2 is equal to a times 0 minus 2 times 0 minus q. And that's going to give us that 2 is equal to negative 2a times negative q, which is going to mean that 2 is equal to 2aq, and that therefore 1 is equal to aq, and that gives us that q is equal to 1 over a. And that means that our general equation would become y is equal to a times x minus 2 times x minus 1 over a. Okay, alternatively, we can say, since we know that it has a general form of the equation y is equal to ax squared plus bx plus c. Well, first of all, we know that when x is 0, y is equal to 2, so we know that c, therefore, has to equal 2. Now, when we go in, we can substitute for the point 2, 0. We can therefore say that 0 is equal to a times 2 squared plus b times 2 plus c, which we now know is equal to 2. That gives us that 0 is equal to 4a plus 2b plus 2. And what I'm going to reset it therefore is by setting 2b is equal to negative 4a plus 2. I'm sorry, minus 2. And so we're going to get negative 4a minus 2. And that means that b is equal to negative 2a minus 1. And we can rewrite our equation, therefore, as y is equal to ax squared plus negative 2a minus 1 x plus 2. If you multiply this equation out, you're going to get this equation, which is how we want things because we don't want the two different methods to yield two different solutions. So they are equivalent. Okay. Challenge. What is the equation of the quadratic that has a focus point at 2, 2 and a directrix at y is equal to 0? All right, so we have the point 2, 2, and we have the directrix at y is equal to 0. So the distance, let's say point xy, the distance to the directrix is just the distance from y to 0. So we have y is equal to, and then we're going to have the distance from xy to 2, 2 would be x minus 2 squared, or the square root of x minus 2 squared plus y minus 2 squared. We square both sides, get y squared equals x minus 2 squared plus y minus 2 squared. Now again, what we said was that if we look at this point xy right here, we find that its distance down to the line y is equal to 0 is just equal to y. Its distance from xy to 2, 2 is calculated by making this a right triangle and figuring out that this distance here we can find by using the Pythagorean theorem. We're going to get that this horizontal distance is just equal to the horizontal distance from x to 2, or x minus 2. The vertical distance from here to here is just the vertical distance from y to 2, or y minus 2, and that's where we get our x minus 2 squared plus y minus 2 squared here. All right, when we multiply this out, we're going to get x minus 2 squared, I'm going to just leave that for now, plus y squared minus 2y plus 4, minus 4y. And we're going to get y squared. We're going to cancel out the y squareds on both sides. So we're going to just erase this. We're going to get 0 is equal to x minus 2 squared minus 4y plus 4. And that means we're going to get 4y is equal to x minus 2 squared plus 4, or y is equal to 1/4 x minus 2 squared plus 1. This is our vertex form. And we now know that it has it's a quadratic with this equation, and we know that its vertex has to be at the point 2, 1. And we also know that it has this a. It's going to change the shape of it. It's going to take, let's say, x minus 2 squared, and because we're multiplying it by 1/4, it's going to make it a broader, wider quadratic. Okay, we also could have ended up with the equation x squared minus 4x plus 8 all over 4, or 0.25 x squared minus x plus 2, or even another version of that.